Yes. Yeah. Actually, before discussing the motion gravity, we'll discuss here motion bonding questions here. Motion bonding. Motion in bonding. Okay. So one of the questions here we're discussing is the two ends of a train, two ends of a train moving with constant acceleration, moving constant acceleration passing a certain point, passing certain point, velocities u and v respectively. The velocity with which velocity so the middle point of the train passes the same point. The velocity with which the middle point of the train, this is the same point is the velocity is options. First option u plus v by 2 is equal as third option u square plus v square under root by 2 and fourth option square root of u square plus v square. What you have to understand here is two ends of a train moving with constant acceleration pass pass a certain point with velocity u and v, and you're asked to find what is the velocity which is the middle point of this reaches. So this can also be treated as something like a particle is moving with so two ends of a train are crossing a point, certain point with velocity u and v means this is right. Right? This is two ends of the end. This is first end, this is second end. I mean last end. So at this point, if you say this has crossing with velocity u, and this is crossing with velocity v, two ends of the train moving with constant acceleration past a certain point with velocity u and v. It is similar to a particle entered a point with a distance. It has obtained a velocity v here. What is the velocity in between these 2 points? This is the kind of question. This is similar to this kind of question. Is this clear? What is the velocity between these two? Let us take it as some v dash. In this kind of case, the velocity is increasing gradually. Right? Velocity is increasing gradually. So we can say, let us say the mid. This is the midpoint of these two. Let us say the distance between these 2 points is x or s, and this distance will be s by 2, and this also will be s by 2. Okay, then you can say by applying what you call, because it is moving with uniform acceleration, whatever acceleration with which it is crossing, moving this distance, the same acceleration will be covering this distance also. By using one of the equations of motion here, that is v square minus u square is equal to 2as. Here, if you say this is v dash square minus u square, v dash square, or I can take it as v at the center, v at center. So v at center square minus u square is equal to 2a is by 2. 2 to cancel here. Let's take it as I have taken only this distance, half of the distance, just by 2 distance. So it is equal to a into s. Let's take this as equation 1. And next, for the next part, v square minus vc square is equal to again 2a s by 2. And also we'll get what? Just you can say it is equal to as equation 2. Understood? Now, yeah. So you want to find the velocity at the midpoint, center point. So for this, is this as by 2. What shape is link? Right. Divide this. So if you divide this, what you will get? 1 by 2 gives you bc square minus u square by v square minus vc square is equal to as by as. Here as cancel. So this is the question, guys. We are discussing this question. When the two ends of a train moving with constant acceleration at a certain point with velocities u and v respectively, the velocity which the middle point of the train passes the same point is. So options are given. To understand this, we have to just consider that. We have to consider that. It is similar to a body crossing a point with the velocity u and with constant acceleration obtains a velocity v after crossing this point. At midpoint, if the velocity is vc, if you compare with this situation, you can calculate the velocity required here. By applying this equation of motion this for this case, you can write for the first half and for the second half these two equations. And by dividing these two, you will get this. So you can say from this, you can rewrite this as simplifies bc square minus u square is equal to b square minus bc square. This minus bc square, if you bring it here, becomes plus bc square. Bc square plus bc square becomes 2 bc square is equal to b square minus u square. If it comes here, it becomes plus u square. So you can write it as u square plus b square, right? So now we are asked to find velocity at the midpoint, right? So vc square is equal to u square plus b square by 2, and hence vc is equal to square root of u square plus v square by 2. So we will get this. And by that formula, next question. The body starts from rest. Body from rest. What is the ratio of? What is the ratio of distance traveled by the body distance traveled by the body during the fourth and third seconds? Body during the fourth, 7.5, second option, 5 by 7, third option, 7 by 3, fourth option, 3 by 7. Right. Let's see. And they're asked to find this given what you're asked to find, it is given that the body starts from rest. its last state is 0. What is the